Okay, we're going to learn section 6.3, polynomial functions. I gave you guys before you left some handouts for this section. On the first page, it will say study guide and intervention. That's the sheet we'll do at the very end. So go ahead and flip that over, and that's where we're going to be in just a couple of minutes. So let's get started. There's a little bit of review I can do here because some of this we've talked about already. They're going to ask you to look for the degree of a polynomial. What you do is you look for the highest exponent. First off, sometimes the terms are not in order. It's nice when the highest one is sitting at the front like it should be, but sometimes it's not. Let me show you some examples. Like this one, the highest exponent, he's sitting in the front. X to the 6, if you look, that's telling you your degree. Your degree is x to the 6, so your degree is 6. I think they ask you another question on those homework. They ask you for the leading coefficient. The leading coefficient would go with the highest exponent, so your leading coefficient is 11. So you would answer that problem just like this. Degree is 6 and leading coefficient is a positive 11. So here's another sample. This one looks good at first. Looks like our degree is going to be 4, but when you go all the way through the problem, you've got more than one variable. And so you actually don't have to put the degree for that one. You just say not in one variable. Okay? So those aren't too bad. So if we took this back one off, you would say degree of 4, and the leading coefficient would be 14. So that's what you're going to do on those. Then you've got some problems that, I don't know why, they stick in this section. I want to remind you how to do this because something is going to come up in the next few days, and that is finding f of 2 for the f function, x cubed plus x squared minus 9. And what we do there is everywhere the x is, here and here, you replace it with the 2. Just be careful if the replacement number is ever a negative, because when you go to do that on the calculator, you'll need to use parentheses. But since it's a positive 2, I can rewrite my problem. You just need to work this math out. You can actually type that in the calculator just like that if you want to. Or you can take each piece, 2 to the third is 8, 2 squared, 4, and then minus 9. And then order of operations, don't forget that. So this is definitely a review. And so the answer is f of 2 equals 3. That's how you answer that one. And so they give you a bunch of those. I think they're asking you to do f of p of negative 6 and p of 3. So you're actually going to have 2 answers. My suggestion is always do an odd first and see if you're getting that right. Make sure everything looks normal to you. Okay. Now we're going to get to some of the handout that I gave you. So you should be looking where it says even, it's along the side. It says even degree polynomials and odd degree polynomials. I'm going to draw these out. The first one looks just like the parabola that we've worked with quadratics before. Well, these are both considered even degree, like an x to the second, because both of their arrows are pointing in the same direction. Okay, so keep that in mind. Even degrees, they go in the same direction. Let me show you another one. So here's a crazy one that you've got on your sheet. These arrows are both in the same direction. And then both of these arrows are in the same direction. So these are all the even degrees. All right? Anything like that, x to the second, x to the fourth, x to the 6th, x to the 8th, the arrows always point in the same direction. So now that I've said that, you can probably guess about the odd degrees. They're going to be opposite of each other. See how this arrow points up, but this one points down. So he's an odd. And here's the other one that's on your handout. See? Different directions. And then here's the bottom one there. And then here is, and this one looks crazy. Does a little something here, and it comes on down. So again, odd. They're at odds with each other. That's how I always like to think about it. They're broken down into 2 columns with the positive leading coefficient. If you remember with parabolas, if it was a positive coefficient, it opened up. If it was a negative coefficient, it opened down. Same thing for all these others. If it's an even degree and it's pointing up, then that means its leading coefficient was positive. For this even degree, if it's a negative, then the 2 arrows will point down. On this one, positive because as you approach it left to right, you end positive. And I think for this one, same thing. As you approach left to right, it means you're ending with a negative. See, we're under the negative. So you end negative, you end positive. So now I need you to look and flip that page over, because I got to talk to you about notation, end behavior of a function. So you're going to need to find this paper that looks like that. You see it? Just flip it over. It should be on the back of the one we were just looking at. I need you to understand this crazy notation right here. You see that says f of x approaches positive infinity as x approaches negative infinity. We're looking at this parabola, and so let me explain to you what this means. I also do it in reverse. I usually start off with the x. So let's start here, and then we'll end with the function, because it just makes more sense, because you always start, like if you're making a table, you start with the x. So as x approaches negative infinity, so think about that. These are your x's. As the x goes to negative infinity, look, this arrow goes up positive infinity. You see that? Ooh, didn't mean to do that. So if we look at this same picture, x approaches positive infinity, so that would be the x's go out to positive infinity. Look, the arrow goes up positive infinity. Okay? The next one is when you have an upside down parabola. So again, I always start with the x's. So as x approaches negative infinity, which would be this side, the graph goes to negative infinity. Look how low that's going. As x approaches positive infinity, then the graph goes down to negative infinity. By the way, to draw the little infinity, it's a sideways 8 if you want to do that. So let's look at, see if I can pull this down to see my other ones. Okay, so these are odd degrees. See, x cubed. So as x approaches negative infinity, it's going down to negative infinity, matches. X positive infinity, so the graph goes to positive infinity. So let's look at this one. So as x approaches negative infinity, then the graph approaches positive infinity. X approaches positive infinity, look where he goes. He goes down to the negative infinity. And so when they ask you about the end behavior of a function, that's what we're going to do next. We're going to look at, and we're going to write it in this same notation, but I wanted you to see I am starting with the x. And I say, well, when I do this with x, this is what happens to the function, because I think that makes more sense. So let's go to the worksheet now, the 6-3 study guide. I'm going to have the bottom portion of that sitting right here, so I can answer these with you guys. So the first thing we have to do is describe the end behavior. Okay, so that was what we were just looking at. So let's look at number 1. So I'm going to say as x, and it doesn't matter. You can say, you can start with the x approaches positive infinity. I think I probably will. All right, so as x approaches positive infinity, so that would be out here. What's the graph doing? Well, the graph is going to positive. Do a little arrow, and then positive infinity. Okay? And then I have to do the other side. So go back to the graph. So as x goes to negative infinity, the function, he goes to positive infinity. So that's the first part. I think I'll use a capital A. And then the next part, what's the B part? Determine whether it represents an odd or even. That should be easy. They're both pointing in the same direction, so it's an even function. And then the last one I haven't talked about, but we've done this so much with quadratics, I think you get it. To state the number of real zeros. That doesn't ask for the exact zeros. They just want to know, basically, how many times does this thing cross the x-axis? Well, there's a bunch. 1, 2, 3, 4, 5, 6. Oh my. There are 6 zeros for that problem. Now, we don't have to find them. Thank goodness. So, number 2. So, number 2. Oh, he's a quadratic. We're used to this one. Okay, so let's do x approaches positive infinity. So, we're over here, so he's there's a little bit showing. But right through here, he's going negative. He's going down. So he goes negative infinity. So as it goes out this way, he goes down. So what about on the negative side? So as it goes out this way, also the function goes to negative infinity. All right, so that was the A part, B part. It's even, they're both going the same direction. And then how many zeros? Looks like it's just one. Okay, just one. And we know that's an x squared even function. Okay, third one. A part, let's do x. Come back. What's it doing? There we go. Go back, here we go. So x approaches positive infinity. So, oh, he's going negative. So, he's going negative. And then as x approaches negative infinity, wow, function says I'm going to go positive infinity. See, he's going up. Okay, now this one is our only one on this sheet here. That's an odd function. C part, how many times it crossing? 1, 2, 3. All right. So keep both of these sheets out as you work through your homework problems, and please, please check your odds. Make sure everything's making sense to you.